Now let's see about Peterson solution. In order to solve the critical section problem, there are two solutions. The first solution is software solution and the second solution is hardware solution. Here the Peterson solution is nothing but the software solution. So Peterson solution is mainly useful in order to solve critical section problem. Peterson solution is nothing but a software solution. We know what is a software. Software means a program. Program means a collection of instructions. So we can say that Peterson solution is a program which is useful in order to solve the critical section problem. Here we can use the Peterson solution only when there are two processes which involves critical section. That means when two processes shares the common code, then only we use Peterson solution. Suppose if the system contains more than two processes, then Peterson solution is not possible. So that is the first point here. We can use the Peterson solution to solve a critical section problem only when the system contains only two processes. If the system contains more than two processes, then Peterson solution is not sufficient. We have to use some more algorithm. Let us assume that here we have two processes, P0 and P1. Next, here we are using two data structures. The first one is int 10. So 10 is an integer variable. 10 indicates whose turn it is to enter into the critical section. Here the value of the turn may be either 0 or 1. Suppose if the turn value is 0, then it specifies that P0 enters into the critical section. Suppose if turn value is 1, then it specifies that there is a possibility that P1 may enters into the critical section. So here the value of turn may be either 0 or 1. Now let's see the next data structure. Boolean flag of 2. Boolean means it may hold either true or false. Here flag is an array. The size of the flag is 2. So that means it holds either flag of 0 value or flag of 1. So the value of flag of 0 and flag of 1 may be either true or false. Suppose if flag of 0 is true, then it specifies that the process P0 is interested to enter into the critical section. Suppose if flag of 0 is false, then it specifies that P0 is not interested to enter into the critical section. Here the initial values of flag of 0 and flag of 1 are false. So it denotes that initially both the processes such as P0 and P1 are not interested to enter into the critical section. So this is about the data structures which we can use in the Peterson solution. Now let's see the solution here. Structure of process Pi. While of true, so it specifies that the condition is always true. So this block is nothing but entry section. This is nothing but critical section, whereas this statement is nothing but entry section, exit section. So first, the entry section will be executed. So in the entry section, the first statement is flag of I is equal to true. So it specifies that the process Pi is interested to enter into the critical section. The next statement, turn is equal to j. So it specifies that Pi is giving the chance for j to enter into the critical section. So turn. So what is the use of turn? It indicates whose turn it is to enter into the critical section. So that means the process Pi is giving a chance for the J to enter into the critical section. Next, while flag of J is equal to true, and this is nothing but logical and operator, and turn double is equal to J. Next, at the end of this we use a semicolon. So that means we know what is logical and. If both the conditions are true, then the result is true. So if both the conditions are true, then it specifies that the process Pj is in the critical section. So Pi has to wait. Suppose if one of these two conditions is false or both the conditions are false, then Pi enters into the critical section. So if these two conditions are true, then Pi remains in the critical section. Pi remains in the while loop. So let's check about the conditions. So what is the first condition? Flag of J is equal to true. So it specifies that the process Pj is also interested to enter into the critical section. As well as if turn is equal to J, then that means if both the conditions are true, it specifies that Pj is interested to enter into the critical section or Pj is already in the critical section. So Pi process has to wait in this condition, in this while loop. So that's why we use this semicolon. Let us assume that the process Pj is not interested to enter into the critical section. So this condition will become false here. Why? Because process Pj is not interested to enter into the critical section. So false to logically it means false. So when one of the condition is false, then the entire result is false. So whenever the condition is false, then the control comes into the critical section. Next, the corresponding process Pi executes the critical section, and if it's completed its operations, then Pi comes out from the critical section. So whenever process Pi comes out from the critical section, then it executes exit section. In the exit section, it executes a statement as flag of I is equal to false. So it specifies that Pi comes out from the critical section. So now Pj can enters into the critical section. So this is about the structure of process Pi. So let us take the code for Pj and P1. Let us consider about Pj. So what is the first statement? Flag of 0 is equal to true. So it specifies that Pj is interested to enter into the critical section. Next, turn is equal to 1. So that means it is giving a chance for the other process, that is P1, to enter into the critical section. Next, P0 is checking whether P1 is interested to enter into the critical section or whether P1 is already in the critical section or not. So while flag of 1 double is equal to true and turn double is equal to 1, if these two conditions are true, then it specifies that P1 may be in the critical section or P1 is interested to enter into the critical section. So the P0 process has to wait until P1 process comes out from the critical section. Suppose if one of the condition is false, that means suppose if this condition is false, flag of 1 is true. Suppose if this condition is false, that means suppose if P1 is not interested to enter into the critical section. So false true means false. So the entire expression is false. So the control enters into the critical section. Next, process P0 completed all its operations in the critical section. So once P0 completed all its operations, then it comes out from the critical section, and in the exit section, it executes an operation called flag of 0 is equal to false. So it specifies that P0 is no longer belongs to the critical section. So now the process P1 may enter into the critical section. So likewise, we have written the code for P1 also. First, if P1 wants to enter into the critical section, then it executes a statement like flag of 1 is equal to true. It specifies that P1 is interested to enter into the critical section. Next, 10 is equal to 0. That means the process P1 is giving a chance for P0 to enter into the critical section. Next, P1 will check whether P0 already entered into the critical section or whether P0 is interested to enter into the critical section or not. So that's why it is checking whether flag of 0 is equal to true or not. Suppose if flag of 0 is equal to true, then it specifies that P0 may be in the critical section or P0 may be interested to enter into the critical section. Already it sets done as 0. So that P1 process will wait until P0 process comes out from the critical section. Suppose if P0 is not interested to enter into the critical section, then its flag value is false. So this condition will become false now. So if one of the condition is false, then the control comes out from the while loop. Next critical section will be executed. So that means P1 executes its shared code after completing its operations. Then P1 comes out from its critical section and it executes a statement called flag of 1 is equal to false. It specifies that P1 no longer belongs to the critical section. Now P0 can enter into the critical section. We know that any solution to the critical section problem must satisfy 3 requirements. The first requirement is mutual exclusion. The second requirement is progress. The third requirement is bounded waiting. So now we have to check whether Peterson solution is satisfying these 3 requirements or not. So what is the first requirement? Mutual exclusion. So what is mutual exclusion? The critical section should contain only one process at a time. The other process should be allowed into the critical section only when the critical section is free. So that means if the critical section contains a process, then no process should be allowed to enter into the critical section. So at a time critical section should contain only one process. So let's check whether it is possible or not. So let us assume that P0 is interested to enter into the critical section. So it executes this statement, flag of 0 is equal to 2. Next, it executes a statement, 10 is equal to 1. Next, it executes the statement, flag of 1 is equal to true and 10 double is equal to 1. Initially, P1 is not interested to enter into the critical section. So this is false. Whereas 10 is equal to 1, this is true. So false true means false. So the control comes out from the while loop and P0 enters into the critical section. Now, P0 is available in the critical section. Now check whether P1 enters into the critical section or not. Now, let us assume that now P1 is trying to enter into the critical section. So first, it executes the statement, flag of 1 is equal to true. Next, it executes the statement, 10 is equal to 0. Next statement, flag of 0 is equal to true. But what is flag of 0? What is flag of 0? Already P0 executed its flag value. Flag of 0 is true. So the value of the flag of 0 is true. True double is equal to true. Condition is true. So that means critical section already contains P0 process as well as what is turn value? 0. So both the conditions are true. So that means the process P1 has to wait until the process P0 comes out from the critical section. Now, let us assume that P0 completed all its operations in the critical section and P0 comes out from the critical section. So whenever P0 comes out from the critical section, then it executes a statement called flag of 0 is equal to false. So now what is flag of 0? Now P0 is not in the critical section and it executes a statement called flag of 0 is equal to false. So now let us assume that the process P1 wants to enter into the critical section. So P1 executes this condition. So flag of 1 is equal to true. Next 10 is equal to 0. Next, while flag of 0 double is equal to true. But what is flag of 0? Flag of 0 is false. So false double is equal to true. So this condition is false. Next, this condition is true. So false true means false. So the entire expression is false. So the control comes out from the while loop and P1 process enters into the critical section. Now P1 is in the critical section. Now P1 completed all its operations and after that it executes a statement called flag of 1 is equal to 0, flag of 1 is equal to false. So with this we can conclude that at a time either P0 or P1 can enter into the critical section. So we can say that the first condition, that is the first requirement, that is mutual exclusion, is satisfied. At a time either P0 or P1 can enter into the critical section. Now let's see the second requirement, progress. So what is a progress? So progress means, so now let us assume that the critical section is free and several processes such as P0, P1, P2 are interested to enter into the critical section. Then the decision about which process should enter into the critical section should be taken in a finite amount of time. It should not be postponed for a longer period of time, and we have to consider only the interested processes which are comes into the critical section. So not interested processes should not be considered here. So that is nothing but progress. So progress means out of all the available processes, we have to consider only the interested processes which should enter into the critical section, as well as the corresponding decision should be taken in a finite amount of time. Let us assume that we are executing P0, and here we are executing the statement while flag of 1 is equal to true. Let us assume that now P1 is not interested to enter into the critical section. So what is the initial value of flag of 0 and flag of 1? The initial value of flag of 0 and flag of 1 is false. It specifies that initially P0 is not interested to enter into the critical section, as well as P1 is not interested to enter into the critical section. So initially P0 executed a statement called flag of 0 is equal to true. So it specifies that P0 is interested to enter into the critical section. Next time is equal to 1. So that means P0 is giving a chance for P1 to enter into the critical section. Next, while flag of 1 is equal to true. But what is flag of 1? The initial value of flag of 1 is false. That means P1 is not interested to enter into the critical section. So that means here the processes which are not interested to enter into the critical section, so those processes are not considered here. And here the decision is taking in a finite amount of time. So that means here the P1 is not interested to enter into the critical section. So obviously the condition will become false. So P0 comes into the critical section. So if you take this one, let us assume that this block is executed fast. So flag of 1 is equal to true. It specifies that P1 is interested to enter into the critical section. 10 is equal to 0. That means the process P1 is giving a chance for P0 to enter into the critical section. Next, it is checking whether flag of 0 is true or false. But the initial value of flag of 0 is false. It specifies that the process P0 is not interested to enter into the critical section. So P0 should be not considered now. So we can say that the progress is also satisfied. Why? Because here we are considering only the interested processes, and the decision is taking in a finite amount of time by checking only one condition, that is this condition. And now let's see the next one, bounded waiting. So what is bounded waiting? The decision about which process will enter into the, here bound means there should be a bound. Bound means there should be a limit on number of times a process can enter into the critical section. When other process request to enter into the critical section, let us assume that this is nothing but a critical section. P1 is in the critical section and P2 sends a request to enter into the critical section. But critical section contains P1. Let us assume that P1 completed all its operations. So P1 comes out from the critical section. After that, assumes that P1 also put a request to enter into the critical section. So now there is a combination between P1 and P2. So which process needs to be entered into the critical section? Let us assume that operating system given a chance for P1 one more time. So assumes that P1 completed all its operations and P1 comes out from the critical section. One more time P1 puts a request to enter into the critical section. One more time operating system giving a chance for P1. So here bounded waiting means there should be a bound, there should be a limit on number of times a process can enter into the critical section. If other process is waiting to enter into the critical section, so only a limited number of times we have to allow P1 to enter into the critical section. Otherwise, P2 starvation will occur for P2 and P2 process will die. Okay. Let us check whether bounded waiting is satisfied or not here. Okay. So what is bounded wait here? We have to give a limited number of chances for a corresponding process. If you consider P0, so whenever P0 comes out from the critical section, then it sets its flag value as false, so that it specifies that P0 is not interested to enter into the critical section. So during that time, P1 can execute its load. So what is flag of 0 here? P1 flag of 0. What is P0 flag of 0? False. So false double is equal to true. So this condition is false, so that P1 can enter into the critical section. So likewise, so for P1 also, whenever P1 comes out from the critical section, it executes its flag of 1 value. So flag of 1 is equal to false. It specifies that P1 is not interested to enter into the critical section. So the process P0 will be given chance now, so that the chances will be given for each process to enter into the critical section, so that there is no starvation will occur here. So we can say that Peterson solution is the best solution in order to solve the critical section problem with the help of a program. So this is about the Peterson solution.